Hey, welcome back. We are now all set to understand heap sort algorithm. I hope you have understood all the heap operations by now. If you still find the heap operations like heap adjust or heapify as challenging, then my request will be to review all those lectures in this section, starting from the very first one and then get back here to understand the heap sort, as heap sort uses heapify and heap adjust algorithm extensively. So here we go. That's the given array with 9 integers that we need to sort in ascending order. The first thing is that you need to build a heap from that array elements. And we can do that just by using the heapify operation. So the first thing we do in the heap sort is that we call the heapify to build the heap. If your intention is to sort in ascending order, then build a max heap. Otherwise, if you are looking for descending order, then build a min heap. The heapify builds the heap for us, and for that it doesn't require any extra space. The heapify is going to build the heap in the same array. I hope you remember that the worst case time complexity for heapify is big O of n, that's linear time. So using the heapify, we can build the heap in linear time without any extra space. Now since the heap is built, we can start the heap sort procedure. As I said during the introduction, that the heap sort is another kind of selection sort, that it selects the next element for its sorted section from a heap. So it goes in this way. We start a loop with a loop counter, say I, that is initialized at n. That's the size of the initial array. For this example, n is 9, so I is at 9 at the beginning. Now we delete the heap on each iteration and place that deleted value at index I after adjusting the heap just after the deletion. On deletion, as you know, we always get the largest number from a max heap, and that we put at the end on each iteration. We also do the necessary adjustment of the heap by calling the adjust for root, so that the next largest number occupies the root. So here it is. We take the content of the root, that is of index 1, in a temporary variable temp. So temp gets 80 for the first time. Now since we are deleting the root, so we need to copy the last element into the root. That's how we delete the heap. I have explained heap deletion earlier, right? So the last element at index 9 is 30, that is copied to index 1. Now we need to adjust the heap for index 1. So we call the adjust operation for index 1, and that rebuilds the heap. Since the index 9 is now vacant, we copy 80 at index 9. Please note that heap is maintained from index 1 to index 8 now. Index 9 is not part of heap anymore, as we have deleted one element from the heap. So total number of elements in the heap is now 8, and they are there maintained from index 1 to 8. This time we get 70 in the temp from root. That's the next largest number, as you can see. We do the same thing. We copy 25 from index 8 to root, and then we call the adjust again. When the heap is adjusted, we copy 70 in temp to index 8. Again, we iterate back in the loop and repeat the same logic. This time we get 65, and 45 goes at index 1. Then adjust operation restores the heap, and after that we copy 65 to index 7. You can see that the sorted section is building at the end of the array. From index 7 to 9 is now sorted, and index 1 to 6 is unsorted, and that's a heap. So the heap is maintained from index 1 to index 6. So we iterate back again, and this time we get 50 as the next largest number. 30 is copied to the root, and after adjusting the heap, we copy 50 from temp to index I, and that is at index 6. Now you see that we get 45 as the next element. We do the same steps. After that we get 40 from the root, and after adjusting the heap at root, we copy 40 to index 4. Then we get 30, and we do the same steps. Copy last element, that is 20, to root, and then do the adjust, and after that copy content of temp to index I. Now we are on the final iteration. This time we get 25 and I is at index 2. Since there is only one element in the heap, after this, so we will stop after this iteration. So we copy 25 to index 2 and we are done. The array, you can see, is sorted now. Here is the heap sort algorithm. You can see that we are calling the heapify first to build the max heap. Then we start iterating using a loop that starts from I equals n, and that goes on as long as I is greater than equals 2. Within the loop, we take out the content of root into the variable temp. Then we copy the last element at index I to index 1, that is to the root. Then we call the adjust operation to adjust the root. After that, we are assigning temp to index I. Now the complexity of heapify is big O of n. However, the deletion takes big O of log n for each element. And that means in order to delete one element, it's going to take big O of log n. And that I have explained earlier when we did the heap deletion algorithm, right? Since there are n elements in the heap tree that we delete in the procedure of heap sort, so altogether it's going to take n log n. So the worst case complexity of heap sort turns out as big O of n log n. So that's all for the heap sort. I hope you have understood the logic clearly by now. In the next tutorial, I'll show you the implementation of heap sort using C programming, and after that using the Java as well. Thank you for watching.